All right. Well, good evening, everyone. Thanks for everyone for joining. This week, let me just mute everybody here. There we go. So this week we'll do our club business at the end of the meeting because we've got Bill and Pete are going to be presenting our main topic for us this week, this month, and Bill's over on the East Coast, so it's pretty late for him. So we'll start with the main topic first and get started. And then once they're done with their main presentation, then we'll come back and do our usual club business at the end. We'll do it last. So Bill and Pete, I'll hand over to you. And let me bring up your slides and then we'll get started.
Great.
Kevin, do you still want to do the thing of questions as we go along, or you want to do it at the end? It doesn't matter. We talked about that yesterday. So what's your preference?
Either way that works for you. If you want to take questions during, that's okay. We can do that, or
yeah.
At the end. Either way.
Yeah, that might be easier. This way we won't have to remember everything all to the end there. So
yeah,
anyway,
okay.
Maybe I'll just start off here, Bill, and let you chime in. We're so delighted to be with your club and to talk about homebrewing. And I should give a definition. Homebrewing has nothing to do with making liquor. Homebrewing has everything to do.
I'm out of here.
Put parts together, and we're going to talk about the fine art of smoking parts. And I should tell you that my XYL is very happy that I'm participating in this event because with this COVID-19 stuff, I had to comb my hair, I had to shave, and I had to put my favorite shirt on that was minus the food stains. So I've got my when you know stuff you can do stuff t-shirt on this evening. So she's happy that I look a little spiffy. So but anyway, Bill, you want to chime in here and just make a few comments?
No, it's a real pleasure. Any chance I get to participate in anything with Pete Juliano is a privilege. So I'm always thankful that we're able to do that in our once a month SolderSmoke podcast. We've been doing it for many years now, but this is a special treat to appear in his native California.
Yeah,
here we are from the East Coast. So
yeah, there you go.
So take it away, Pete.
Okay, next slide, Kevin. Okay, there's a secret to the nerd style of homebrewing. First off, you have to have a pocket protector with tricolor pens. If you don't have that, you can't really participate in the homebrewing. And those of you who worked in aerospace, like my history, you had to have the pocket protector and the badge. And of course, there's my buddy there, Napoleon Dynamite. Next slide, please.
Pete asked me if I actually had a pocket protector with multicolored pens when I was in college, and I said no because I was a liberal arts major.
Next slide. Here's just a quick tour of kind of what's happened to our hobby going back to the 1950s, and it's interesting to see the big impact in the early 1950s. Of course, was the introduction of transistors, and we saw some amazing things from like Collins Radio with a KWM1, KWM2. There was still a lot of home brewing going on, but as you progress through the 60s, 70s, 80s, and 90s, it got to be more commercial equipment and not so much of the impact of people actually building the rigs. You know, when the hobby first started, everybody built everything because you couldn't buy it anywhere. And if you were an amateur, you built all your own gear, built your home station. And we had predominant names like Collins and Helicrafters and National and Hammerlin and Heathkit and Eldeco and Ico and Nightkit and Drake. I mean, these were household names in the amateur community. And then as we find in the 2000s, they're all gone. Those people don't exist anymore. So it's kind of a sad thing. But I think there's a resurgence today in homebrewing. And a lot of that resurgence is a result of the impact of the availability of cheap technology, the availability of a lot of neat hardware, things like microcontrollers and Raspberry Pis. And now we find that there's an integration of the computer with our hardware. And so either it's controlling or you're building a keyer or you have the frequency control, or in the case of the SDR radios, the whole thing is done. A $35 Raspberry Pi forms the basis of an SDR transceiver. So it's just kind of interesting to see how our hobby has progressed. And what's more amazing and kind of sad is not many manufacturers here in the U.S. are making amateur radio equipment. It's all coming offshore. And You look at any of the ads today, it's all not coming from China. So it's just a matter of time. But
You
it's
know, one
just
thing,
kind of interesting. Go ahead, Bill. Jump
no,
in.
I was just going to say, Pete, one of the things that always struck me about your chart is it's a reminder of how recent radio is in human experience and how far back our own personal connections with radio reach into that history. We have more than half of radio history. If you figure, if you date it back to Marconi's original transmissions around 1900, this is more than half of it right here. And Pete and I know many of you have equipment in our shacks that reach back that far. I mean, I have Drake equipment, I have Hallicrafters equipment sitting right here in the shack. It's still working, and that's half of radio history right there.
There's two important pieces of information on this chart, and it kind of blows your mind. If you look at 1960s, you look at SBE 33 and 34. SBE, the sideband engineers 33 and 34, was the first hybrid rig to hit the market, and that was started by Faust Gonset. And SBE, before it finally went out of business, was acquired by Raytheon. Now, if you fast forward to 2010, 2020, you see Flex Radio and entering the scene. Today, Raytheon and Flex Radio are developing the latest communication systems for the U.S. Air Force. So, the two companies that had their hands or touched amateur radio are now developing the latest communication system for the United States Air Force. It's just it kind of blows your mind. I mean, Gerald Youngblood had this idea, and now that idea about software-defined radios is going to find its way into our next generation communication system. Next slide. I put together what I call the 10 Commandments of Homebrewing. Bill always mentions that the radio gods have spoken, so this has a religious tilt to it. And I was just trying to jot down some things here that we need to think about as people who are taking the journey into homebrew. And Bill and I are real solid on this point. Noodle first. That means think about what you're doing and solder last. I mean, the last thing you want to do is turn on the soldering iron. The first thing you want to do is think about what you're doing. And Bill always says, design then build. Right, Bill?
Yeah, this goes back to my liberal arts comment. You know, it took me a while to figure out that the sequence is really important there. Design and then build, not in the reverse. Because when you get started, you're very often doing it the other way around. You're building like crazy. Then you're thinking, well, listen, I better do some designing because this thing is not working. So the sequence is important. Design, build.
And to that end, you want to start with what I call a requirements list. If you're going to start with a project that you're essentially starting from scratch and coming up with your own piece of gear, build a requirements list. What do you want this thing to do? I mean, it's terrible to get halfway down the pike there and suddenly say, gee, I wish it had this capability, and you have to literally destroy what you've built. So if you come up with a requirements list first, it helps to focus the design and how you're going to do things. And number 4 is kind of interesting, is the final enclosure should be the first thing on your list of determinations. That picture below there is actually a breadboard, which is 18 inches wide and 2 feet deep. And that was my attempt to transistorize a Heathkit HW101. So I had it all on the breadboard, and I operated it that way for about 2 months, and I decided I wanted to put it in a box. And it took me almost 8 weeks to get it into the box because I didn't think about how you're going to package this thing later on. And so many times when you start a project, you also need to think what I'm going to put it in. And Bill has some good examples of what he's done with that, and we'll see that a little later on. The other thing is we need to collect data, and you need to look at resource documents and information, and you need to create a file system. Bill, I think you use notebooks. Is that what you do?
Yeah, lately I've drifted to folders because often I'm working on something and I'll just be jotting notes on a piece of paper or on a piece of grid paper or something like that. And what I'll do is periodically just throw everything in the folder. So each of the rigs that I've built has its own folder that if I suddenly start thinking, okay, well, listen, what did I do with this rig that I worked on 4 years ago? I just pull out the folder and I can find my notes. I find it's a convenient way of doing it.
Yeah, because later on you may not need to fix something and you say, oh, geez, where did I put that information? If you have a folder or a notebook, then you're able to go back and, retrace your steps.
I just want to say something about
Yeah,
Pete's picture about the
sure.
HW101 on the board there. We've come up with a term for this. This is called al fresco radio, right?
Yes.
And the thing is, we have become kind of enamored of this. So there's a temptation to leave it exposed, leave it on the board so you could see all the electronics, let it all hang out there, but Pete's right. Eventually it has to go inside the box, sadly.
Yeah, if you want to move it around somewhere, you
Yeah.
need the enclosure. You need to plan your build, and there's different ways to do this. And my bent on this is if I'm building like a receiver, I start at the end. I build the audio amplifier first, and I get that working. And I tend to build like a number 7 build-in module. So I've got the audio amplifier module. I've got that working. I can put it off to the side. And the next thing, I build a product detector and I'll get that working and I move that off to the side. And then the next thing is like the BFO, and I can test that system out. So essentially, you having the test module instead of trying to just go build everything all at once and then you try to put it together and it doesn't work. You have no idea what may not be working. Whereas if you do it in modules and if you build each piece as you go along, then you're very certain about that works, that works, that works, and there's no question about what's not working. And again, I can stress building on in modules because you may want to change something. And instead of destroying the whole radio to make a change, if you just change a module, like I want to do a different audio amplifier, I just disconnect a couple of wires, put a new module in there, and boom, I'm working again. So it makes some sense that you're able to make changes. And I always consider it, and I think Bill, you feel the same way. You call these experimenters platforms because we're always tinkering with something, we're always changing something. So if you build a module, you can do it quite easily.
Yeah, building it by
Number
modules and building it by stages is really, really key. And I think back when my early home brewing experience as a teenager, I would get this schematic from QST and I would just start building it. And I would look at it as just this kind of collection of parts and wires. And I didn't see it as a collection of stages. And seeing that circuit as a group of stages, each with its own function working together, is important. We recently had we sometimes get people ask us for advice on how to approach a homebrew project. And we made this point. We said, look, make sure you're building it as stages. And the fella came back and very honestly said, look, I'm looking at the schematic and I really can't even see the stages. And at that point, we said, well, look, you probably need to take a step back, because that might indicate that you're taking on a project that's more than you can handle right now. So take it easy, slow down a little bit. When you can see them as stages, when you understand the circuit, then it's time to think about building.
Yeah, absolutely. The number 8 is really critical. Is don't apply power unless you want to have a giant smoke test until you've verified that you have the right parts in the right place, no solder bridges, no shorts, and all the connections are made, and you have power to all parts of the circuit. I had a project here a couple of years ago. This guy in the UK says your circuit sucks; it doesn't work, and he sent me some photographs of what he built. And I looked at the one of the transistors had no power connection to it, and I said, "Go look at that." I said, "You don't have power to that circuit. No wonder it doesn't work." So it's just a way of checking things so that you don't blow anything up, and you're assured that you're going to have success when you do power it on. Also, when you test modules, be sure to document the results. And of course, the smartphone is a real easy way to do that. I mean, if you have an oscilloscope and you're taking oscilloscope readings, take pictures of that and then put them in your folder. Because then later on, if you have to do some troubleshooting, you'd say, well, like when I first built this thing and it worked, I was seeing these voltage levels or this kind of a signal level, or this is what the signal looked like. Then it helps you to signal trace or troubleshoot what the problem may be. And again, the point of sequential testing of the modules, your built work becomes a part of the test system. So, I mean, I've got my BFO, I've got my product detector, I've got my audio amplifier. And then when I put the IF stage ahead of that, that now becomes part of the test system. And Heathkit used to do that. You know, when you've built any of the Heathkits, they say, okay, build all this, I'll test it. So this way as you go along. But by the way, if anybody's interested in building a solid state version of the Heathkit HW101, the link there to www.jessystem.com has that project completely detailed with all the schematics and photographs. So if you get the urge, you want to build a solid state version of the HW101, you go to that link and you'll find it there.
It's pulling me in,
Next
Pete.
slide.
It's pulling me in. I'm feeling.
Yay! There you go. There you go. Next slide, please.
You take care of yourself.
Was that a question? I'm sorry, I didn't hear that.
I don't think so. I was muting a few people there. If there's any background,
Oh, okay.
I'll try and mute
Okay. Okay. What you see here is a project that I built about 10, 12 years ago. This is a state-of-the-art CW. That's what SOTA stands for. State-of-the-art CW transceiver using 4 MMIC devices. And I got a question about what MMIC means. And MMIC in the electronics side of the world means monolithic microwave integrated circuit. This thing is like a pill. It looks like a large size head of a pin. And think of it as a wideband amplifier up into the gigahertz, the microwave region. It typically has a Z in and out of 50 ohms. And these things are good for about 20 dB a gain. So they're just like a building block. And you don't have to worry about adding, transformers or coupling coils or tuned circuits. It's just wideband. And you got to be careful because here in California, MMIC stands for Medical Marijuana Identification Card. So we're soldering, not smoking. So just so we know what a MMIC is, it's a monolithic microwave integrated circuit. And a VTO is a varactor tuned oscillator. And we use DC voltage to tune this. If you bias the diode, it has a junction capacitance. That capacitance changes. So in some cases, diodes specifically made for this may have a 50 picofarad, from 2 volts to 10 volts. And in that situation, you're able to tune the circuit with a DC voltage. So it's not like you have a capacitor out there that's going to be effective with hand capacitance. You're just tuning the pot, but you do need a regulated supply. The upper board on the left is the transmitter, and the lower board on the right is the receiver, and that is roughly 3 by 4 inches. And it was just kind of an interesting exercise to try to see if you could build something. But this works quite well. It's got break-in, all the things that you'd kind of want. And as a matter of fact, I've stagger tuned the transmitter because there's a heterodyne crystal. I stagger tuned that with a receiver so it has built-in side tone. But it was kind of a neat project to build. And it's just something you can do. And this thing will compete very, very well. And right now I had to reconfigure it a little bit. I blew out some parts. And right now it only does about a half a watt, but that's plenty for communications. And if you look at that link that's in the description there, there's complete description how to build this thing with all the parts list and all the schematics. But I know you're engaging in building that new, what is it, the Tune Tin 2 Plus. And so obviously that's a CW transmitter, but this was something I did in 2009 that lets you get on the air with a really compact box. So next slide, please.
Excuse me, Pete, we have a question in chat from Peter.
Yeah.
K6RFT asks, do you recommend using lead solder or some other alternative?
Lead solder is the only way to go. Forget that that compliance stuff. It just doesn't stick. So I always try to find the lead solder.
Okay, thank you.
Okay, this next project, there's a link for YouTube. You can watch this. There's an interesting story about this project. This is a radio in a wooden box. When I was a kid, I think it was a Popular Electronics story about this young lad. He was 13, 14 years old. He built a transceiver in a wooden box, and he'd take it out in the woods. He'd throw an antenna over a tree limb, and he'd operate from there. And that always struck me. So as kind of a neat project. And I came along about 10, 12 years ago with the wooden box. So I said, oh, time to build that radio. And actually, this is an interesting architecture. This is not a transceiver, it's a trans receiver. So essentially it's a separate receiver and a separate transmitter, but there's one common element, and it's the VFO. So that if I actually separated the two boards, I could put two VFOs in there and I'd have a standalone receiver and standalone transmitter. This thing works quite well. I haven't had it on the air in a long time, but it's on 20 meters. And one of the first contacts I had blew my mind. I talked to Portugal from Seattle, Washington, when I was living in the state of Washington. And this thing only puts out 4 or 5 watts. So you can make DX contacts with something that you build. And I mean, I got a real buzz out of that. And in that YouTube video, the link there, you'll see the QSL cards, and you can actually listen to that radio, how really gun it is. I put an LM380 audio amplifier in there. You can't use headphones with it. It powers the speaker, so it's really kind of nice sounding. But it's just the idea of how taking something like a wooden box and packaging your radio inside of that, and it works very, very well. And of course, the National Velvet Vernier Dow really makes it work well. It gives it extra mojo, right, Bill?
Oh, it's very important.
You got to have the mojo. Okay, next slide. And you can do things pretty simply. Here is a CW transceiver that I rolled my own. Up in the left-hand corner is a discrete audio amplifier, a little 5 megahertz VFO. The has a 3-pole crystal filter at 12 megahertz, so the subtraction of the 12 and the 5 gives you 40 meters. It's got a little RF amplifier on it. The TR switch is a double-pole, double-throw toggle switch, so I can just throw it one direction is receive, the other direction is transmit. Bill, you do this quite a bit, don't you? Use the toggle switch.
I like the toggle switches. Yeah, it's a simple, very simple way to do transmit to receive changeover. Sometimes a toggle switch combined with a few electromechanical relays.
Yeah. So this is on a wood plank. This is al fresco, and the transmitter module is actually crystal controlled. So if you had 2 or 3 rocks, kind of tough to make a lot of contact with one rock, but if you had 2 or 3 rocks, strategically placed in the 40 meter band, like 70-30, 70-23, maybe 70-45, you can make quite a few contacts. This thing will put out about a watt, and it's on a little board. It's kind of neat to have something like that. Just for occasional contacts, it's something you can build and get the joy out of operating yourself. Next slide. There are some key homebrewing concepts, and Bill just talked about this a few seconds ago. Start with small projects, 1 or 2 transistor transmitters. I had a guy that built a flashing lid project, and he contacted me about building an SDR transceiver. I mean, that is a giant leap. and Bill, chime in here. You get emails just like I do about, hey, I'd like to take this on, and they don't have a clue.
Yeah, I mean, it's a matter of, it's understandable. They see a rig that they like and they think, I want to do that, I want to build it, but they don't appreciate that by taking on a project that's beyond their capabilities, they're almost setting themselves up for failure, and it's a disappointing failure. So it really does make sense to start small, a 1 or 2 transistor transmitter, like you're doing with the Tuna Tin 2. Also recommend direct conversion receivers. A very simple receiver, direct conversion receiver. It's relatively easy to get going, and you build up experience. You become more confident in your ability as a builder, and you have gone through the process of building something, seeing it not work, taking a breath, working on it some more, getting it to work, and then you say, okay, and then you could do that on a larger scale. So it is important, I think, not to bite off more than you can chew when you're getting started.
Right. There's another really important piece to this. Learn how the circuits actually work. Just building something teaches you nothing, and you're going to have a really good opportunity with that, with the project you're undertaking now. It's a nice circuit board. Carol shared with me her completed module, and of course, it's got the SI 5351 in it, and the Arduino Nano, and it's flashing lights and all that. But as you're building that project, take a look at the schematic and understand what all those parts are doing, because that teaches you how the circuits work. And it also is helpful if you got to fix something, you'll have the knowledge about what pieces are not working right because you understand the circuits. So I mean, it's a learning journey. It's not just stuffing the board with parts, it's learning how it works, and that's even more meaningful when you actually put it on the air and you're making contacts. You'll understand why everything is working the way it does. And I can't overemphasize the extensive use of simulation, things like LT Spice. Now, I think yesterday, Kevin, you mentioned that they had a class last year on LT Spice. Is that correct? Your club had a class on LT Spice. Did they do that last year? Or Carol
Yes,
said
yes,
that.
we did. Yes.
Okay, that is really important. Let me give you a real practical example. Most of the builds I make are sideband transceivers. I made a few CW transceivers, but most are sideband. And I typically have a go-to circuit with a 2N3904 microphone amplifier. And I put this thing on the air, and I kept getting reports like, well, you sound okay, but your signal has no lows in it. It has no presence. You're just missing all the lows. And I just said, well, I'll speak lower. Will that help? No, they said your signal lacks lows. It just sounds like it's great for DX, but not good for rag chewing because you're emphasizing the highs. So I took I took the one transistor circuit, I put it in LT Spice, and I ran the plot, and I said, yeah, I know why, because I looked, it started amplifying at 600 hertz. So everything between 300 hertz and 600 hertz, the low end was missing. So I made a couple of capacitor changes and then ran the plots in LT Spice, and I got down to 150 hertz. So I no longer get complaints about your signal lacks lows because I was able to. It was two capacitors I had to change, two capacitor changes, and LT Spice gave me the answer. I mean, I could have sit there looking at that thing all day long and not realize it. And I know, Bill, you might want to chime in about LC too, because you use LC a lot.
Yeah, LC's it's a simulator. It's basically a simulator for capacitive inductives resonance circuits, and you could plug in values there to find out whether your filter is going to filter out what you want, whether it's going to pass what you want. All these simulations, LT Spice, LC, and a number of others, really just help you kind of confirm that you're on the right track. And if you build something and it's not working, then your question is it because I built it wrong or is it because there's a design flaw? What you do then is you build it in the simulator and you see if it works in the simulator. If you see that it's working in the simulator, then you think, well, it's probably because I built it wrong. One other word of caution: schematic diagrams in ham radio magazines are notoriously filled with errors. Notorious. I
Oh
mean, when I
yeah.
was a kid, I would see these things. I would get QST. I would think, this is the Bible. This is from ARRL headquarters. Everything in here has to be right. And it was just wrong. And you'd build it and it wouldn't work. And you didn't really understand it because, like Pete said, it's important to understand it. Because I didn't understand it, I couldn't spot the error. But you know, be prepared. There are errors in those schematics, and I guess that's just part of the game.
Yeah, the other thing too, and you're going to hear this all the time, a common thing: document the simulation and validate with measurements. And what I'll frequently do is I'll print out the LT Spice simulation, and then I'll make the measurements, and I'll put them right on that the printout of that simulation. So then I know, and that's one piece of paper. I can see what I did, and I have the measurements, and that helps when you troubleshoot later on. And again, the modularity, it's a living experimenter's platform. You'll hear us say that, and it's over and over again, because if you want to make changes, you only have to change one board, not the whole radio. Next slide. Now, building concepts. You hear a lot of talk about ugly construction. And I guess my bent on this is ugly is just that. It's ugly, but I think it's also a problem where you just start soldering things to a circuit board, parts hanging all over the place. And unless you're pretty careful, certainly that works. But boy, it could be prone to shorts and errors. There doesn't give you any, real track of what you're doing. And I kind of prefer using something different than ugly. Now, Wes Hayward, W7ZOI, I mean, he swears by ugly construction. You look at some of his projects and they look a little ugly, but they work well. But unless you're very, very careful, you can bring wires too close to each other. And you move things around, you're going to short something out. Then you don't know where you're at. So I prefer something else. The Manhattan Squares, the me pads from W1REX, Rex Harper sells these. These are breakable. These are a board that comes with all these squares that are plated, and it's on an isolated pad, and that you see it's a product detector balance modulator on the right hand part of the screen, and you can just break these off for how many you need. And the thing that's nice is they're already pre-10, so you can solder right to them. And then what you do is essentially glue those meat pads down to a copper substrate. And so then the outer part is ground. So you want to ground something, you just take it to the outside of the squares and solder it right to the copper board. And that works quite well. And that, they're a little bit expensive, but if you're judicious in how you use them, you can save a lot of money. Bill, you want to chime in? I know.
Yeah, I just was going to say, I don't want to take any any business away from our friend Rex Harper and the meat pads up there in Maine, but I make my own, and I do it with a tool. It's available in Home Depot. It's tin shears. I've had the same one for years, and I start with just a piece of PC board material. Here it is. And if I know that I have to connect 2 or 3 components together, I'll just cut off a little piece. Boom, there, I've got a small piece for it now. I super glue it to the copper clad board, let it dry for a couple seconds until it gets stuck there. And then any components that need to be soldered above ground are soldered to this. Any components that need to be soldered to ground go to the copper substrate. Now, this is called the Manhattan method because you end up with these kind of square or rectangular looking objects glued to the board. And when looked at from above, it looks like the grid square street pattern of Manhattan Island. That's where the Manhattan pads come in. But I think I like it. I always do. I constructed it this way. It's not as disciplined or as organized as Pete's, but I really have come to like it. And you get into kind of a way of building, and that's the way I build all my rigs. It's super glue with pads on a copper clad board.
Yeah, cool. Another one that I like very much is a single-sided copper vector board. The perf board typically is non-conductive, but you can buy, so one side is conductive, and it's kind of expensive. But if you if you need to make a ground connection, because it's like the perf board, it's a 10th inch squares, you just run a resistor capacitor through it and solder right to the top of the board, and you got a great ground plane. And if you're not soldering to the ground plane and it's through hole, then you just take a little drill bit and you remove some copper around the hole, so as the part passes through there, it doesn't short. And then you do all the wiring, point to point wiring on the other side. And the thing that's nice about this is you can put sockets on here, you can put parts on here, and from a rapid prototyping standpoint, it works very, very well. And of course, the solid copper ground plane makes a big difference because you're not running long wires to ground. Something needs to go to the ground. It's right at that part and works real well. And of course, the other building concept is what you're doing with your project. You had boards made in China, and I gotta say, if you have the artwork, they're dirt cheap. I don't know. I think your boards are what, buck a piece or something like that, a buck or $2 a piece. I mean, that's amazing. You get this nice quality finish board with plated through holes, and everything's laid out, everything's all compact, and makes building pretty easy. And it's not like you're paying $5 or $10 a board, and especially a $10 bill probably gets you $2 worth of shipping, and you get 8 boards and $2 worth of shipping for $10. You're in business for quite a bit. Now, a popular approach today is also the use of a CNC mill. Now, I have a CNC mill in my shop, and it cost me $250,000. That's what my CNC mill cost me. I should explain. The reason it cost me $250,000, the mill was built by my son, who's a mechanical engineer. The $250,000 would have cost me to send him to engineering school. So when he was done with school, he built me a CNC mill and says, "Here, we're even." So he paid off his college debt by building me a CNC machine. But it's pretty nice because that board there below, that was all done. I just laid it out using some free software, and then you essentially just solder right to that board. And I think the benefit of that is, if I want to build a second or third or fourth one, all I do is chuck a piece of board in the CNC mill and push the start button, and I'm ready to go. So it makes it kind of nice. Now, CNC mills, you can buy a suitable mill to do small type boards like you would have, for our hobby, in the $200 to $300 range. I mean, these things were $700 to $800 here about 2 years ago. Now a good device will cost you about $200 to $300. As a matter of fact, I saw one the other day, kind of a small tabletop. It not only is a CNC mill, it's a laser cutter, and it's also a 3D printer, and it's under $500. So I mean, you get a 3D printer, a laser cutter, and a CNC mill all in one machine. Got different heads they put on it. Well, think about it; it's all CNC controlled. So, the basic software to operate this thing is, and the controller is all the same. The controller doesn't care if you got a mill head on there, you got a 3D print head on there, or you got a laser. So I mean, that's where this thing's heading. And I guess probably a year or two from now, you get those for $350. So that starts putting in the realm of something you might buy to support your hobby. Next slide.
Pete, I have a
Yes.
couple of comments here from Phil, KD6RM. He's one of our DIY radio group leaders. Phil, if you want to unmute yourself, you can ask your questions there. If not, he's
There we
saying-
go. Actually, a couple of things. Up until the past couple of months, shipping on boards from China was dirt cheap. But our current project, I think the boards were like $1.20, and the shipping worked out to be almost $2 a piece.
Oh, okay.
There's a change in how the Postal Service was subsidizing the Chinese industry. The other thing I wanted to mention is, in this day and age, the good old dip packaging for semiconductors is disappearing rapidly.
Yeah.
A lot of the newer stuff is SMD, surface mount devices. And I'm kind of curious how you approach surface mount. I will tell you, for the past 10 years or so, I came across a method that works for me. I actually use a machinist caliper to scribe lines on copper clad. And then with a straight edge and a razor knife, I cut out the traces for the individual portions of the circuit, again, in a modular fashion. And I use that good old wire wrap wire to do the interstage coupling. Makes it easy to swap things around. So again, breadboarding with surface mount devices is a bit of a challenge. And it's pretty hard to ignore because that's pretty much all you're going to get your hands on these days.
Well, yes, that's true. And I have converted a lot of my designs to SMD in the CNC mill. So I just punch the button and I got the SMD pads right on the mill. Although there's some things that you can get that are pretty cool. There's a place in Florida called Marlin P. Jones Associates. And they sell these carrier boards that will take the SMD parts, and they're arranged so that you just put a set of pins in them and you can plug them in a socket. And the carrier boards for like 8-pin dip or 14 or 16, they're like 59 cents. Marlin P. Jones. So you
there's a lot of those in the marketplace.
Yeah. But I mean, from my standpoint, I've shifted a lot to surface mount, and I've just taken the time to do the layouts and I typically use graph paper to do the layouts in a program called G Simple, and then I'll just put it in the mill and say, okay, I want a surface mount of this particular circuit board, and I'll just do it there. As a matter of fact,
if you're doing circuit hacking and you're trying to develop your own circuit, it's fine if you have a proven design, but in the process of hacking, it's kind of tough to CNC mill each and every approach.
That's true. That's true. Yeah. So I would probably go to the carrier board for the initial prototype, and then convert that. Once you got it working, do it with a surface mount and use the CNC to do that.
Should I talk about the BitX, Pete?
Yeah, go.
Yeah, this is a good,
Notice,
it's actually a
notice
good-
how that GIF worked in there, Bill. I was amazed how that worked.
well,
Cool.
actually, this is a good segue from the question because I am kind of old school, and this is a rig that was built with no surface mount parts. It's also a rig that was built with no integrated circuits. I like to build my rigs with discrete transistors because I think for me, it's easier to understand how the circuit's working without using, little boxes that have, dozens or hundreds or even millions of transistors in them. So I kind of keep it discrete component transistors, leaded parts, and that's the way I build it. This is the BitX, the bidirectional transceiver. This is a design done by a good friend of ours in Hyderabad, India, Ashar Farhan. Farhan designed this rig about 20 years ago now, and he designed it in one overnight flight from Europe back to India. He had with him only the calculator that was in his phone, a notepad, and some pencils. And that was the birth of the BitX. It was designed to be a low budget, simple, easy to reproduce monoband SSB transceiver. He designed it with economy in mind so that you could buy in India at the time all the parts that you needed to build one of these things, and you would spend less than the rupee equivalent of $5 US. This is a $5 SSB transceiver. Now, what I'm showing you here is a couple things. First, look at the right. It's the noodling. This is what Pete was talking about. I started with like a blank canvas, and that is the copper-clad board that you see there. And I decided, okay, this is the board on which I'm going to build my BitX transceiver. I had the schematic from Farhan. Then I kind of plotted out the territory on the board. You could see where I took a piece of paper and I just said, okay, this is where I'm going to put the various stages. This is the importance of seeing the schematic as stages. So I put the stages and I sort of plotted out the real estate on the board. Then I began to build, and you could see the different stages as they are populating the board. Now, when I finished one stage, I would not move to the next one until I tested it. The very first stage I built, I differ from Pete in this a little bit. I usually build the oscillators first. See, I figure if I get the oscillators going, that's a major hurdle. So first I built the oscillator, and then I started building amplifier and mixer stages, each one tested as I went along. So by the time I got to the end, I knew all these stages worked as they were supposed to work. And when I connected them all together, it was a very easy transceiver to get working. Now, the final picture is on the left. And this is, again, a kind of a variation from what Pete said. I really didn't build it thinking about what kind of box I was going to put it in. I should have, but I didn't. I built it on that board. And then I went down to Michael's, the craft shop, with a board of the same size, thinking that I was going to find some material to build a box for this thing. And I stumbled across this kind of soft wood box, and the board fit perfectly. It was almost as if the radio gods wanted this thing to be placed in the wooden box. So I bought one of the boxes. It's a wooden box. It's like a cigar box. I put the board in there, and that is my BitX 17 transceiver. But anyway, I just show you that because that shows you, I think, the importance of building by stages, testing by stages, and noodling before you begin the project. Maybe we should go to the next slide, Pete.
Yeah, go ahead. Next slide.
All right, now this is a rig. Sometimes you get into projects just because they're a bit of a challenge. Now, the truth is that Pete and I are not real big CW guys. We're mostly sideband of kind of operators, but we both cut our teeth on CW and we're both quite good at it. So we can do CW, and there's an advantage, and the advantage is simplicity. CW is very simple. You turn the thing on and off. So here is probably one of the most simple CW rigs that you can build. This was originally called the ET1, the Experimental Transceiver 1. In that the 1 stands for it only uses one active device, one FET transistor, one MPF 102 transistor or J310 transistor, just one. And that is one that is used for both transmitter and receiver. So you have a switch, a big toggle switch. And the guy who designed this was a fellow named Glenn Yingling. And he managed to get that transistor to work as a regenerative receiver on receive, and a single transistor transmitter on transmit. I tried it. I couldn't get it to work with just one. So I splurged. I used two. All right. So I used one transistor for the transmitter, one transistor for the receiver. Now, at any given time, I'm only using one, but I cheated a little bit because I wasn't switching between the two. Anyway, now this is a really simple, low parts count transceiver. I would not recommend it for a beginner, because here simplicity actually makes it much more complicated to get on the air and to actually work somebody. I really had to use all of my decades of ham radio experience to actually make contacts with this thing. And I made 20 contacts with it on 40 meters over the course of a couple months. Whenever I made the contact, I was so proud of the contact, I would take a Sharpie and write the call sign of the person I spoke to on the board or on the PC boards, so that at the end of the whole exercise, there are 20 call signs now, like tattoos all over this thing. And it has become wall art in my shack. It is now hanging up on the wall in my shack. I took the board and I put some hanging material on it, and it is now on the board there. Anyway, it put out about 100 milliwatts, I think. The regenerative receiver worked really fine. It's amazing what you could do with a receiver, especially a receiver with just one transistor. And there you'll see that over there, you'll see the crystal, and then there's like a blue potentiometer. That's the entire transmitter circuit. The key is from India. Farhan brought me the key, and all the circuitry on the left-hand side, the big variometer, the big variable cap, that's the regenerative receiver. A lot of fun with that. Anyway, it's just a kind of a curiosity, but it was a fun project. Maybe the next slide. Next slide, I think, has to do with project that you're working on here now.
Oh, it's you.
Yeah. Yeah. Anyway, this shows you, I'll show you another picture of this, but this is actually a transceiver called the Fish Soup 10. Now you're working on the Tuna Tin 2, and there was a time when the ARRL and QST was putting out, for some reason, rigs with fish cans of fish as the theme. They were using like the Tuna Tin 2 was built on a tuna can. Well, they came up with a receiver that was called the Herring Aid 5 and the Tuna Tin 2. And then there was a VFO for the two of them called the CB Slider. All right. But I built, I'll show you the next slide, but this is a combination of the Herring Aid 5 receiver and the Tuna Tin 2 transmitter. I had to build a VFO for it, a VFO. That added a few additional transistors. So the two of them combined, I called it the Fish Soup 10, because there was a total of 10 transistors in the whole thing. Now, this kills Pete because that is my frequency readout. So this is 7.040, 050, 060, 070 right there, right? And that little black plastic thing, that's the pointer, okay? So that's how I know that I'm operating between 7040 and 7050 kilohertz, okay? But I'll show you the next slide because there's some Tuna Tin 2 lore here. Please go to the next slide if you could. All right, there it is. This is the Fish Soup 10. Now the box that you see on the left-hand corner, that's the Herring Aid 5 receiver. I tried to build this as a teenager. I was about 16 years old. I tried to build it. I could not get it to work. I worked on it. I etched the boards. I worked on it and worked on it. I could not get the thing work. I gave up. It was a bitter disappointment for a teenage ham radio operator. Now, we didn't have the internet. I really didn't have anybody I could turn to. And when you're 16, you don't think, well, I'm going to write a letter to somebody. That's just outside the planning range. So the thing failed. I built it again 38 years later. I decided I was going to take another shot at it. I found the schematic, built it again. I couldn't get it to work again. I couldn't get it to work again. I got a friend of mine in New Zealand, Dexter, spotted it. He said, you wound the coil wrong. The tickler coil on the oscillator was wound in the wrong direction. Well, QST didn't tell me how to wound it in the right direction. But anyway, we fixed it. We got it sorted. Anyway, that became the receiver. Now the box in the back is the actual tuna tin 2. I actually had built it on a tuna tin, on the circular thing, on a circular, like a tuna can, but I put it in the box here, and that is the tuna tin 2 transmitter. And of course the VFO is in the upper right. So this became a kind of a 1/4 watt transceiver for 40 meters. And I made lots of contacts with this. I had a lot of fun with it. And it was a kind of a combination of projects from the radio past. Now, I have actually held in my hand, I'll just mention this to you real quickly. I've actually held in my hand the original tuna tin 2 from QST and the ARRL. I think Doug DeMaw built it. I think he was the one. But Rex Harper, who we mentioned earlier, the guy with me pads, was the custodian of this device for a while. And he brought it to a ham fest where I was, and we staged a ceremony. Pete mentioned Mojo. We staged a ceremony in which Rex officiated and transferred the mojo of the original Tuna Tin 2 to the BitX 17 transceiver that you saw a few minutes ago. And I think that's one of the reasons my transceiver works so well. But anyway, we're getting into metaphysics here. I think that's about it. So I think that's all I have to say about these rigs. Well, maybe we could have some questions later, but I go to the next slide and carry on, Pete.
Yeah. You have to have a lot of imagination if you're going to do home brewing. And the slide on the left is called Thinking Out of the Bottle. And essentially what that slide is, this is a champagne bottle, and you can see it there. This is a champagne bottle. It's a plastic bottle that I bought some candy that was champagne infused candies. I got it at Costco. When I picked up the bottle, I realized it was Lexan. So I decided to build a transceiver. That's a 40-meter single sideband transceiver built inside of a bottle. In the center there, about 10 years ago, I decided to build a solid state version of the KWM2. And that's an all-band transceiver. And you notice the front panel looks like the Collins escutcheon that you typically see on the Collins rigs. I built that on the CNC. And it does have a Collins mechanical filter, and it's a dual conversion rig, and it even tunes from a keypad. 2 of the keys in there you can tune up in frequency or down in frequency. So today you could do a lot more with the technology that is available to you, but this works really well. And every once in a while, I like to get on the Collins net on Sunday, and I check in, and they ask you what rig you're running. I say I'm running a KWM4, and of course everybody says there is no such KWM4. I said, oh yeah, there is. It's sitting in front of me, and that's the rig there. Down below was a stab I took at building a pretty simple single sideband transceiver using only 9 transistors, and it doesn't have a lot of frills, a lot of bells and whistles. As a matter of fact, there's a guy in the UK took a look at the design. He said, well, it doesn't have an AGC in it. It doesn't have this. Well, the intent was it wasn't going to have all those things. It was just a basic transceiver that would work and put out a good signal. And as a matter of fact, I have a digital adapter I designed for that you can operate FT8. To the right is a 16 cubic inch single sideband transceiver operating on 20 meters. And there's the actual rig right there. It's got a variable crystal oscillator. There's 2 crystals in there. It gives me about 60 kilohertz. And it's all within the box. It puts out about a 1/2 watt. And this was the subject of the article that appeared in QRP Quarterly. So we have a lot of technology available to us, and you just need to think about it. And some of these are pretty complex projects. The solid state version of the KWM2 is actually kind of a follow-on to a project I saw in the GE Ham News. In 1959, 2 guys designed a thing called the LWM3, where they essentially built their own version of a Collins KWM1 as a mobile rig, and they had a pair of 4CX250s in the trunk. So it was a little more than a QRP rig. Had a little juice to it. And it took them a year to build. And I saw that and I said, why can't I do that in solid state? And I did. And that took me about 3 months to build. So you can do a lot of things when you don't have to work. I've been retired a long time now, and so I really enjoy doing it. But just open up your mind, your imagination. There's a lot of technology, and you're really going to see that with the project that your club is undertaking. I mean, just think if you put a analog VFO on that, and you certainly could put an analog VFO on that Tuna Tin 2. but I got to tell you, taming that thing will be kind of tough. But here, the board will fit in the palm of your hand. You got a digital VFO, rock solid stable, QSY up and down the band, and don't worry about it. And what's interesting is you can buy the parts and components for a digital VFO using an Arduino and SI5351. A $20 bill will buy all the parts. So, I mean, we live in a really great time. Next slide, please. Here's a kind of a recap of the key elements. First up, you got to get a pocket protector and tricolor pens. If you're going to homebrew, those are kind of the basic tools you got to start with. And again, noodle first, solder second, and don't just build it, learn why, and acquire some decent test equipment. Now, there's a slug of test equipment that has hit the market. This nano vector network analyzer is especially good if you want to do Smith charts work, or you want to look at networks and see what the response is, the band pass or low pass or high pass filters. They cost about $50. And some of them you can even get discount for about $40. So, you know, it puts within the realm. That's almost like going to McDonald's with a family of 4 and you walk out with a nano VNA. So indeed, it's if you're going to do some serious home brewing, then you need to probably invest in that. Nano VNA is probably one of the best investments you can make. Again, using the simulation programs. YouTube and Google are your friends. Man, there isn't anything you can't think of that you want to build in electronics world. You go to YouTube and boom, there you are. Bill, chime in here. How many times have you fixed things as a result of going to YouTube?
Yeah, I mean, I think YouTube will show you how to do things. Pete taught me how to do tap and die, how to put the threads in there for to put a heat sink on an amplifier. I didn't know. Pete told me about it. I found some other YouTube videos. I learned it a little bit more. Then I produced my own video, and it's got like 35,000 views. People are now using my YouTube video to learn how to do this relatively simple task. But Pete's right.
Yeah, and start with small, simple projects. Now, one that Bill and I talk about is the Michigan Mighty Mite, and let me explain. That's a 1 transistor, not a 2 transistor. It's a 1 transistor transmitter, and they call it the Michigan Mighty Mite because it has so few components. It puts out a couple hundred milliwatts, and it uses the color burst crystal. So you'll find it. What's that? 3579 Bills the frequency.
3579. We had a bunch of them, and we were talking about it on the podcast. And people started writing saying, "Well, I'd really like to build one, but I can't find the crystal." So we would stick them in an envelope. We sent out like 50 of them. So 50 Michigan Mighty Mites were built around the world as a result of this effort.
As a matter of fact, a friend of mine, a fellow ham here in Newbury Park, he wanted to build this, and the 3579 crystals were in some of the older TV sets. And he happened to be in the parking lot of Home Depot, which also had one of these places where you can pass on electronics and clothes and that sort of thing. He spotted an old television. He slams on the brakes, rips open the TV, and takes the crystal. So that's where he got his crystal, in the parking lot of Home Depot. But there's what's really important about the Michigan Mighty Mite: 8 components. But I do recommend, if you build that, put a low pass filter on it, because the output is not real clean. But the thing is, 8 components can teach you a lot about electronics. You can look, it has both AC circuits, DC circuits, bypass coupling. You understand what it takes to create an oscillator, that you have to have the right amount of feedback from essentially from the output to the input to cause this thing to oscillate. And it'll oscillate on a specific frequency because of the crystal. And so it's a worthwhile project, not just to build to say, yeah, I built a Mighty Mite, but to understand the electronics behind it.
But yeah,
So,
and we would tell people that even if it's the only thing that you ever build, because some people are just not going to get into homebrew in the way we have, and that's fine because everybody has different interests. But I would tell people, look, just build the Michigan Mighty Mite, and then you could say to yourself, I built a radio transmitter at least once. I built a radio transmitter. I built something that produces RF energy, right? And today there's a lot of ways that you could actually test it. Even if you're never going to actually work anybody with this thing, you could get on and watch yourself being picked up by the reverse beacon network or by web SDR receivers that are located all around the country. You could see how you're getting out with it. One fellow who built one, who lives very close to me, called me up and said, can you get on 75 meters and see if you can hear me from across town? That was Dean, KK4DAS, and I could hear him. So I said, wow, you worked all the way from McLean, Virginia to Falls Church, Virginia. Congratulations. It was great fun.
Yeah. And again, I want to emphasize building of circuits and modules and document things using your smartphone. So these are kind of just a recap of the key elements, and you have a great learning journey with the project that your club has undertaken. You get a real chance to build a working piece of hardware. You're going to have something that's compact, it's going to work well, but also take the time to learn, understand what that Arduino is doing with the SI5351. How is, with two transistors, how is the signal being generated? What is the import of the low pass filter and the output? What are the value? What application of the bypass capacitors? Everything that goes in there. Take time to understand what that is, because then that becomes a knowledge base that you build on from the future. And again,
Yeah, that's it. I would just say throw one thing here. And I got my start in ham radio by listening to Gene Shepard, who used to run a radio show from WOR in New York. My father and I used to listen to him. Shep was a ham radio operator, and many of his shows had to do with ham radio. And that's how I got my introduction to it. And he would talk about being a ham radio operator as a kid in the 1930s in Indiana. And he projected this image of a group of hams who really strove to understand the circuits they were working on. And they were really scornful, the way teenage boys can be, of people who didn't measure up, who didn't understand the circuit, who didn't really understand what was going on in the circuitry. So I always hear Shep's kind of voice in the back of my head saying, you really got to understand this stuff. And if you don't, well, you're just not worthy.
yeah. Shep had another famous line to what he's done. You ever see the Christmas movie with Ralphie? You're going to shoot your eye out with a BB gun. Remember that?
Yeah.
You see the Christmas? That's the guy that wrote the movie. That's the guy that wrote that story. Yeah. Ralphie, you're going to shoot your eye out.
He narrates the movie too.
Yeah, he does. He does. Yeah, cool. Next slide. Well, here's some reference links for you. First, Bill has the SolderSmoke blog, which he puts a lot of jam-packed information in there, a lot of really good stuff, and you need to visit that every day. I also have a blog that I try to document some of my projects. I have several websites. The JES Systems one has some of the older projects. The n6qw.com radio website. Yesterday, I uploaded a project on there, and you might want to visit that because it has a direct conversion receiver project that's detailed in detail on that website. There's a link. As soon as you open it up, it'll tell you a link to take you there. And what's interesting about this direct conversion receiver, it was replicated by two hams in the UK. So three of us have built this project. It uses an MC1496 double balance mixer, which you can buy from Mauser for about 82 cents. And it is a surface mount version, so you can get one of the carrier boards if you want to plug it into the socket. But the thing that's interesting is the guys from the UK took the design that I came up with, and they have actually picked it apart extensively. So when you click on, there's a link within that link that takes you to the UK site, and they have charts and graphs. They looked at the bandpass filter, and they actually measured it with a nano VNA, and they also showed some different methods of how they constructed that. That particular one that I built was built on the single-sided copper vector board. They did it. One of them used the pads, another one actually designed a board and cut it on a CNC. So it just gives you some good reference. So you may want to look at something to go with your transmitter, and that's something that you could build as a companion if you don't have a receiver yet to go with the Tune Plus. The N6QW Radio Genius, that's an interesting story. GoDaddy contacted me and said, you can have any one of these websites with a US after it for 99 cents. So I said, I got it. What a genius of an idea. So I bought it for 99 cents. And that one is SDR. So if you have an interest in homebrewing an SDR transceiver, that site is completely dedicated to SDR transceivers, and it shows you how to load software, how to take a Raspberry Pi and implement a Raspberry Pi with various types of boards that are available. And it's interesting. We found out over time that typically hams have more than one hobby. Some of them are musicians, some are into photography, others will do, various things. I like to cook. So I have a cooking website, pastapete.com. And if you have an interest in cooking, I have shared some recipes in there, including my secret sauce. The Italian sauce recipe is in there, and there's some other things that you might like to cook. If you like to cook, you might see something that whets your appetite. So, Bill, you want to chime here? Any other things that you like to point them to?
I think it's just a reminder. Pete Juliano is a Renaissance man. He's also a musician. He does it all. So I have nothing else to say.
Yeah, there you go. There you go. Well, Bill, I'm sure you want to say something as well. Thank you for the opportunity to speak to your club. It's heartwarming to see that clubs are taking on projects with the club members, because that's really important that we, make the hobby progress. I bristled a little bit. The IARU here a couple of years ago came out with some kind of a paper that said hams are hams for only two reasons. They like to participate in contests and they like to operate. And I'm saying, wait a minute. There's some of us that like to build stuff. And so it's nice to see that your club is taking this on as a club project, and it may spur interest in doing other things like building a companion receiver, or maybe building a transceiver or what have you. So it's really nice to see that that's going on. So, Bill.
Yeah, I'd just like to thank the club for giving us a chance to talk tonight and giving us a chance to talk about our rigs. Every time I'm on the air and somebody says, could you tell me a little bit more about your rig? I kind of sit back and I say, okay, well, you asked for it. Now you're going to get it. It's like you're like the proud papa talking about his kids and their achievements. So I really appreciate the opportunity to talk about some of these weird creations that we've made. And thanks very much to the club for the invitation.
Although, Bill, I thought you were going to say like the guys that run the Flex 6700s after they find out it's a homebrew rig, and they said, well, what does it sound like, Bill?
No, I hate it. They say, well, what kind of rig? And you say, oh, it's a homebrew rig. And then they say something like, well, I guess it sounds okay for a homebrew rig. And you're like, oh, man. So Pete and I have developed our way to respond. We come back and we say, well, yours sounds pretty good for a Yaesu too, I guess.
Yeah.
But it's all good natured. It's fun. We're just kidding around.
All right. Well, thanks to both of you for taking the time to present for us tonight. This was great.
We do have another question.
Yeah, there's some questions coming in.
Yeah, coming in the chat. Besides the Nano VNA, what do you recommend as minimum for test equipment, and what do you recommend as a reference source for circuits?
Okay, Bill, you want to?
Yeah, I think, well, obviously you need to have a digital multimeter, and it doesn't really matter how fancier it is. It needs to be something that you can measure voltage, resistance, and current with. And these things are available for, $10, but you can get a good one, you can get a Fluke, but get a digital multimeter. And then after that, I think the really essential piece of test gear on a workbench is an oscilloscope. The good news is that oscilloscopes today have become very inexpensive, very reliable, and very capable. Almost all of us are now using Rigol scopes. A Rigol, I'm looking at my bench right now, a Rigol 1102E scope.
Yes.
1102E will go up to 200 megahertz, and it'll cost you new about $300 max, 250, $300. I use it every day. And I know Pete mentioned Wes Hayward. Wes Hayward has one on his bench. Ashar Farhan in India has one on his bench. Pete has one also. So a Rigol scope and a digital multimeter, I think, is a good start.
You asked about a signal source. Was that?
No, a reference source for circuits.
Oh, okay. Well, there's a couple of good ones. EMRFD, Experimental Methods of RF Design by Wes Hayward and Bob Larkin. That seems to be the Bible, but typically they refer to it as EMRFD, Experimental Methods in RF Design. However, I have a personal bent of another Wes Hayward publication called Solid State Design for the Radio Amateur, SSDRA. And as a matter of fact, a while back here, ARRL was selling EMFRD, and as a bonus, you got SSDRA on a DVD. But I would try to find a hard copy. The Solid State Design for the Radio Amateur is a vintage about 1970, 1980s, and I prefer that over EMFRD because to me, it's if you're sort of entry beginning level, SSDRA, Solid State Design for the Radio Amateur, is a good place to enter. There's projects in there, and Hayward takes time to explain them. As a matter of fact, we talked about bandpass filters. In the appendix, it shows you how to hand calculate a bandpass filter. And that is a worthy exercise to understand how you get all those values of capacitance resistance. Whereas EMFRD, the Experimental Methods RF Design, is a little higher level. And of course, if you're interested in a little higher level, that'd be the one. But if you're just starting out and want a basic, that'd be the one. But there's a lot of good publications that are out. Check the ARRL book section. There's a lot of good books in there that start with some basic types of circuitry, and that'd be a good place to start.
I find I need a lot of books, a lot of different books. So I have a fairly big radio bookshelf because some books just don't explain it well to me. And so I look for another book where I say, okay, yeah, this author is presenting the circuit in a way that I can understand it better. So I guess it sort of takes a library. So when you go to Hamfests, look for those boxes of dusty old books underneath the tables, and bring home a couple books every time you go. It'll help. The books that Pete mentioned are excellent, especially Solid State Design for the Radio Amateur. Yeah.
And Kevin and Patty mentioned this book here.
Yes, go, Bill, go.
I heard that's pretty good too.
You're the author of this book. It's an awesome book.
Thank you, Carol.
Yeah, and Bill, I don't think you've seen the latest iteration of the Tuna Tin. This is now married with an Arduino Nano and an SI 5351.
Well, that is beautiful. That's a thing of beauty. It's amazing.
Yeah.
I think Doug DeMaul would be astonished. I'm going to send to you the video of the Mojo ceremony with the original Tuna Tin too, Carol. You could share it with the club.
Okay, any other questions or comments? This is awesome. Thank you for taking the time to be with us tonight. And we will certainly update you on how we're progressing as a club at our build as well. Thank you so much for this time.
You bet.
Thank you,
Take
everybody.
care.
Good night.
Good luck with
Good
your
night.
project.
Thanks,
Bye.
gentlemen.
All right.
Take
Thank
care,
you.
Pete.
Thanks
Thanks.
very much.
Bye-bye.
Thank you. All right. Well, everyone else, if you want to hang on, and we'll just do our regular club business. Jojo, you still on? Do you want to give us an update on our treasury and membership?
Oh, I'm working on the membership sheet right now, but I'm not ready to report anything for today.
Okay. All right. Carol, do you have an update on our social media website?
Sure, I can go ahead and share my screen if that's okay.
Yep, try now.
Okay. Okay, this is an update on our web resources for February. Okay, just a reminder, our web is n6na.org. And we have all of our information of club activities up there, including a calendar, keeps everything up to date. Our nets we have a health and welfare net that meets daily at 7:30 on our main N6NA repeater, 145.25. Then on Wednesday nights, we have our main 2-meter club net, 8 p.m. 10-meter net is at 8:30. And then we have a slow scan TV net at 9 p.m., which is also live stream on YouTube. And we also have a swap page. where we have items of interest for buy or sell. Website activity for February, we had a total of 2,000, I'm sorry. Okay, we had 2,994 page views in February, and most of the views were on the day after our meeting, which was February 3rd. The most active web pages are our homepage. We had 609 page views, 10-meter page, 567, and a magnetic lube antenna project page, 157 page views. Most of the views came referred by Google, 47.3%, and we had direct hits to 6na.org of 27.4%. Most of our views, again, are from the United States, but we have visitors from all over the world, all these different countries. Social media-wise, we had 1,649 views on our YouTube channel, and we now have 293 subscribers. Our Facebook page has 487 followers. Our Twitter page has 139 followers, and our Discord server has 18 members. And just a reminder, if you want to give us any feedback on the website or any of our web resources, you can always send an email to contact@n6na.org. And that's it. And back to Kevin. Thank you.
All right, thanks, Carl. Do we have anything else of interest for the club tonight? Anyone else have any updates or items of interest? Any comments about presentation tonight?
Well, it was marvelous.
It was very good. Yeah.
Those guys do a great job. They're colorful, they're fun, they're adventuresome and enthusiastic. I mean, what more do you ask? And you know, the point that was being made towards the tail end there, this is the greatest time in history to be involved in homebrew. You can get state-of-the-art equipment for a song. You could buy parts for next to nothing, and there's just no shortage of circuits that you can play with, and you've got the YouTube resources to help you along. I mean, it's when I was a kid, it was practically impossible to find any information. You couldn't afford any test equipment, and everything, you know, you had to be a mechanical engineer to put things together because you had to punch holes in sheet metal, and you know, it was just an entirely different time. So now is a fun time to play with this stuff. Not only that, you don't get shocked. You're working with 12 volts instead of 600.
That's a good thing.
Through that. Yeah, and you can turn it on and not have to wait 20 minutes before you can work with it because it had to warm up.
And the smoke lets out faster.
And it's not as toxic. I was muted, so I just want to show that it's been built. It took 2 days, and I got it all done. I have some questions for Thursday. They will wait for Thursday.
Very good, Neil.
Very good.
Yep. We want to put a plug in for this book, SolderSmoke. It's an awesome, easy reading book. Actually, it's a story that this is Bill Meara, who is just speaking with us. He wrote this book, and you can order this through Amazon. It's only $15, or you could also get it as an ebook for, I think, $5. Really cheap. But it starts with his story as a 12-year-old boy, what got him into electronics, and then how he, as he grew up and started working for the U.S. Foreign Service, traveled all around the world and met ham radio operators all over the world, and what an enriching experience it was to him, and what got him into building, starting with that hearing aid receiver he tried to build as a teenager that he finally got to work after all these years. It's a very entertaining and very easy reading, and plenty of pictures in here. I would highly recommend this book. And do listen to their podcast. There's a link to it on our website, n6na.org.
So thank you guys for taking the time and organizing and putting up programs like this. It's really worthwhile.
Yeah, thanks. Carol, this was you, right? You reached out and got in touch with them?
Yes.
Thanks. Yeah, thanks. Thanks for doing that. This is a good one. Yeah. If anyone else has any contacts or knows of someone that might be interested in presenting to the club, let us know if you've got any other ideas of people we can reach out to. Because in some ways, this is a perfect time to get people to present online because, you know, it's easy. You can present from anywhere. So if anyone else has got any suggestions of anyone we can reach out to and ask, let us know.
You know, we had quite a few visitors from outside the area that were peeking in on that presentation.
We did, yeah. I think we were up to like 48 people, I saw at one point.
48, yeah, I saw 48.
Yeah.
In fact, earlier this week, last week, I sat in on the SARS, Silicon Valley, or FARS, Foothill Amateur Radio Society. Bob Mix turned me on to it. Tom Schilling, the antenna guy, made a presentation. It was very well done. So it's not a problem to snoop around. It's kind of interesting. Learn a lot.
Very good. All right.
Yeah. Good
Anything
night,
else?
guys. We'll see you tomorrow.
Yep. Don't forget tomorrow's net night. Okay. We'll hear you on the air.
See you
All right.
when.
All right. Good
Thanks,
night.
everyone. All right. Have a good evening.
All of you.
Buddy.
Thanks. Bye.
Bye.